write the equation x squared over 4 plus y squared over 9 equals 1 in parametric form. This is a conic section equation, and it'll give you a graph of an ellipse. Looks a little bit like that. That's a rough sketch of it, kind of like an egg standing on its end there. To write this in parametric form, we're going to recognize that we have cosine squared of theta plus sine squared of theta equals 1, because this is what our equation, it's already in that form. Well, it looks very similar to this form. Now, if it's not already in that form, if it's not equal to 1, you can divide each side by the appropriate number to get it equal to 1, and you might have to complete the square of the x's and the y's. But in any event, you're going to make it look like this. Now we recognize that it looks very similar here. We've got cosine squared, or at least the structure looks similar. Cosine squared and then x squared. So let's write cosine squared of theta equals x squared over 4. And it's pretty close. It's not there yet. So let's recognize that we need to square the entire right-hand side. So x squared over 4 is the same as x over 2 quantity squared. Now, if you squared this fraction, you would get x squared over 4. Now, at this point, we can get rid of the power of 2 by taking the square root of each side. And now we can write cosine of theta equals x over 2, and then multiply each side by 2, and you get x equals 2 times cosine of theta. So that's one part of the parametric equations. And the parametric equations are going to have an x component and a y component. And so as theta changes, as the angle changes in radians, that's going to give you an x coordinate. And now as theta changes, you're going to get a y coordinate. And we're going to plug in, instead of using y squared over 9, I'm going to say, well, hey, that equals sine squared of theta. So let's write that. Sine squared of theta equals y squared over 9. Again, the whole thing is not squared yet, so let's make it look just like the left-hand side. Good, good. Y over 3 quantity squared is the same as y squared over 9. So now we have something squared on the left-hand side and the right-hand side, so that we could take the square root of each side to get rid of this power of 2. And now then we can write sine of theta equals y over 3. Multiply each side by 3, and you get y equals 3 times sine of theta. Okay, those are the x and y coordinates or components of the parametric equations. Just a note here, if you were to type this into your calculator, you set your calculator to parametric form, and then it'll give you a prompt for an x and a y component of the parametric equations. When you go in to type x equals 2 times cosine of, it'll give you a t for the variable, and that's fine. We still know that we're evaluating t is going to be an angle. It's just that parametric equations are typically written with t as the independent variable. That's all. But we still recognize that that's going to be an angle that we plug in there. And y equals 3 times sine of t. And the reason it usually uses t is because parametric equations are usually given in terms of time. And this could be time, actually. But it just so happens that you're taking cosine of that time. So you're thinking of that time as some radian measurement, and then evaluating cosine of that value. So in any event, that is one example of converting an equation into parametric form.